everyone, my name is Emily Walker, and for my final project, I chose to explore how solar and socioeconomics are related in Massachusetts. Expanding renewable energy is crucial in the fight against climate change. President Biden aims to achieve a carbon pollution-free electricity sector no later than 2035, which will require substantial growth in the renewable energy sector, including significant expansion of solar infrastructure. In the solar industry alone, this target will demand over 900,000 new employees, which represents a four-fold increase from today. Massachusetts is one state that has experienced significant solar growth and will likely continue to be a leader in driving solar expansion across the country. Massachusetts is ranked 8th nationally for solar installations, and the Solar Energy Industries Association predicts that about 1,553 megawatts of solar will be installed in Massachusetts over the next 5 years. Residential solar is particularly attractive to many homeowners because it allows them to use clean energy while also saving money on their electric bills. In Massachusetts, on average, customers see payback periods of about 6.5 years, which is really impressive when you consider that many solar panels come with 25-year warranties and often end up lasting about 30 to 40 years. I created my web application to allow users to explore how residential solar and socioeconomics are related in Massachusetts. A potential user may be searching for a new home and wanting to live in a solar-friendly area. The user could also be a solar installer wanting to find new areas in the state to target for marketing purposes. Or perhaps the user is just curious if socioeconomic factors inhibit residential solar growth in certain areas, which could potentially be remedied by incentives or rebate programs. Overall, solar growth needs to continue, and this application aims to help the cause. The primary data I use for my web application is from Stanford University's Deep Solar project. According to Stanford's website, Deep Solar is a deep learning framework that analyzes imagery to identify the GPS locations and size of solar photovoltaic panels. Leveraging its high accuracy and scalability, Deep Solar constructed a comprehensive high-fidelity solar deployment database for the continuous U.S. Essentially, the project used machine learning to find solar installations across the country and then created a database including this data as well as data from the census, from NOAA, and from energy companies. For my project, I only included data in Massachusetts and only explored a few different attributes that are particularly interesting in relation to solar. The other data that I used for my project is from Esri. I use this layer to display the Deep Solar project data geospatially by joining the two layers together, as I explained in my story map. Next, let's explore how to actually use my web application. When you first open the application, this info box will pop up, which will explain to users how to most effectively use the application. As you move to the right, you can see the Choose Layers to display. You'll want to display one of the two first layers, or both. The first shows the number of residential solar systems, which is adjusted by population within the census tract area. The second layer shows the total number of residential solar systems, which is not adjusted. Below this, you can see the median household income, the daily solar radiation, the percent of the 2016 Democratic vote, the diversity index, or the population. Here you can see a legend of the displayed layers. Next, we can explore infographics related to solar energy in Massachusetts. This infographic just shows some quick stats on energy in Massachusetts. This infographic shows the number of residential solar systems by county. Here we can see the population by county. And here we can see the average daily solar radiation by county. This widget shows a list of the total number of residential solar systems by each census tract area or FIPS area. Here you can see the FIPS area code, the county, and then the number of residential solar systems. As you click each one, it will take you to that area. New solar systems are added every single day. So it's very possible that in your area, there could be a new solar system that isn't displayed on this map. So if you want to update the map to be more accurate, you can find your address here. So I'll go to an address in Somerville, which is where I live. I'll click this area. You can see that there are 10 residential solar systems in this census tract area, but I know there are actually 12. So I'll go back and I will update this number to be 12 and save it. And now this is more accurate and reflective of what I actually observe in my area. After visually exploring some of the relationships between solar and socioeconomics in Massachusetts, you can create a layer that shows areas that meet your criteria for what you would consider to be a good area for solar. If you're not sure where to start, you can use the hotspot analysis tool, which will show statistically significant areas based on attributes. So we'll click that here. Maybe you want to look at the total number of residential solar systems, and you can find clusters of high and low. You can divide it by things if you want to, and then you can run the analysis to create a hotspot layer. But let's say we already know, based on just exploring the map, what we want to explore. So I want to build a query based on an area where median household income is above 100,000, daily solar radiation is above 3.6, and the percent of the Democratic vote is above 60%. So I'll add an expression, and I'll say median household income is greater than 100,000. I'll say daily solar radiation is greater than 3.6. And I'll say that percentage of the 2016 Democratic vote is greater than 60%. Now I can run my analysis. So now that I've created my new layer, I want to bookmark some areas that I think are particularly interesting. So I click this area. You can see some different attributes about it. And I want to add a bookmark for it. So I'll call this interesting solar area, Middlesex County. Now I can see the area and come back to it as I please. Thanks for watching my presentation on solar and socioeconomics in Massachusetts and exploring with me how to use my web application. I hope you learned some useful information and that you continue to learn about solar energy and infrastructure in the United States.